Okay, welcome to Psych 200 Research Methods. Today, we're going over Chapter 8. Okay, we're talking about complex research designs, otherwise known as factorial designs. Okay, what these are complex experiments that have more than one independent variable. And they're a little bit harder to analyze, a little bit harder to understand, but we're going to go over them, and I'm going to give you guys several examples and teach you guys some shortcuts as to how to basically analyze these. Okay, because if you just read the chapter, if there is a chapter on this in your book, I forget, but usually when there's a chapter on this, it gets into really complicated stuff. And I just devised some shortcuts to help you understand. Okay, let me turn up the volume a little bit. It seems a little low. Okay, so let's get started. So I don't even have an outline for you guys. Let's just get right into it. Let's talk about these things called main effects and interactions. When you have factorial designs, you'll have to look for main effects and interactions, okay? And to before I tell you what that is, I'll tell you guys about that with a little example, okay? Now, all of you have probably heard that, you know, there's been studies done on alcohol and aggression. You've at least heard about it from me, okay? I've been telling you guys about this throughout the semester. Okay, there's been plenty of experiments that have been done where they get participants drunk, right? They intoxicate them, and then they give them an opportunity to behave aggressively, right? To see if alcohol has an effect. Okay, so I could just ask you guys straight out, based on what you know, does alcohol increase aggression? Does alcohol make people more aggressive? If your answer is yes, that's called a main effect, okay? A main effect means that there is an effect based on something, okay? That's what that means, that something causes something. There's a main effect. And we'll go through several of examples of these, so we'll make it clear what a main effect is. Okay, so if alcohol increases aggression, that's called the main effect. Now I'll ask you again, does alcohol increase aggression? Some of you might say or might think, well, actually it depends. It depends on whether I'm happy, whether I'm angry, those kind of things, right? Alcohol doesn't always make me aggressive. It depends, right? It depends on the situation. If that's your answer, if you say it depends, that's actually called an interaction. And I'll explain how that is. An interaction is basically when you have an effect that depends on another effect. And we'll talk about that. Okay, so let's go through one example. Okay, here's one study. Okay, it says a study that looks at the effect of aggression due to provocation and alcohol. Okay, so this is gonna, let me just tell you what it says there and then I'll explain. Okay, so it says the following study investigates the effect of provocation, yes, no, on alcohol, yes, no, on aggression. Okay, so the study basically is looking at the effect of provocation and alcohol on aggression. So in this study, participants aren't just consuming alcohol, some of them, right? They aren't just being exposed to alcohol, but some of them are also being provoked, okay? So provocation has two levels, yes, no, right? Some of them are provoked, some of them are not. And alcohol has two levels. Some of them are given alcohol enough to intoxicate them, and some of them are not, right? So this is what we call a 2x2 factorial design. Okay, 2x2, okay? Independent variables are called factors. That's why it's called a factorial design. And the study has two independent variables. One of them is provocation in red there. The other one is alcohol. Those are the two independent variables. And like I said, each of them has two levels or two possibilities. Yes, no for provocation, yes, no for alcohol. So two independent variables, okay? So one of those first two, 2x2, the first two refers to provocation and the first two refers to alcohol. And the fact that it's two means that there's two possibilities for provocation, two possibilities for alcohol. Okay, so it's a 2x2 factorial design. Okay, it has two independent variables and it has four conditions. When you multiply 2 times 2, you get four possibilities, four conditions. Okay, provocation, yes, no, combine that together, right? You can have provocation, you can have yes provocation, yes alcohol. You can have yes provocation, no alcohol. You can have no provocation, yes alcohol. You can have no provocation, no alcohol. There are 4 possibilities when you combine provocation and alcohol, and each of them has two levels there, okay? So it's a 2x2 factorial design, okay? 4 conditions, right? 4 conditions or 4 groups that you need to analyze. If there are 10 participants per condition, 10 participants per group, then you're gonna need 40 participants total, right? 4 conditions or 4 groups times 10 participants each will give you 40. You're gonna have questions like that on your homework and on the exam. You're gonna be given some little scenario like this, and you're gonna be asked, if we are gonna have this many participants in each condition, how many do you need total? How many factors are there? How many levels for this factor? How many levels for that one? So you need to know how to read it. And we're going through that now. Here's what it looks like when you graph the results, okay? So look there. So the y-axis there represents a dependent variable. The y-axis, the one that's vertical, that's the level of aggression from 0 to 12, okay? And then we have on the horizontal axis, on the x-axis, we have, you know, alcohol, no alcohol or alcohol, okay? One of those possibilities. And then look at the lines, right? The pink line represents participants that were provoked, and the blue line represents participants that were not provoked, okay? That's the way the results look when you graph them, okay? You did that study, and this is what you've got, okay? These are the results. And I'm gonna be referring back to this in a moment. I'm gonna show you guys how to find main effects and interactions. Okay, main effects using the graph method. So we're gonna look for main effects now. Remember, main effects means that something has an effect, right? We're gonna look for main effects using the graph method. We're gonna be looking back at that graph and see if we can spot a main effect, see if we can spot things like that. So it says, look at the lines, okay? Are they spread apart or are they close together? So if you look at the 2 lines, there could be more than 2 lines, by the way, but you look at the lines, are they spread apart or are they close together? If they are spread apart, that means there's a main effect for whatever the label for those lines are, okay? An example, there's a main effect of provocation. That means provocation has an effect. So let's go back to the graph so you can see this. So look at the lines, okay? You have the pink line, you have the blue line. Are they close together or are they spread out? Are they spread apart? You can clearly see that they're spread apart. That means there's a main effect. What's the main effect? It's a main effect of provocation, because the pink line represents provocation and the blue line represents no provocation. So those lines refer to provocation. There's a main effect of provocation. That means that provocation has an effect, okay? So those that were provoked, you can see on the pink line there, right? Their numbers are higher than those that were not provoked. Those that were not provoked are, you know, on that blue line there. They're lower, okay? The endpoints there tells you the averages for each, okay? So the pink line is above the blue line. They're spread out, right? That means that provocation is higher than no provocation. There's a main effect of provocation. That's what that means. So I went over that first part. Now, number 2, look at the lines again. Are they flat or at an angle? Are they sloped, right? If they're at an angle, if they're sloped, right, that means there's a main effect for whatever the x-axis is labeled as. Whatever the x-axis is, there's a main effect of that. Example, main effect of alcohol. That means alcohol has an effect. So let's go back to the graph again. Okay. Now it says to look at the lines. Are they sloped or are they basically horizontal? Okay. Are they flat? Okay. So you can see the top one, the one that says provocation, that one has a slope. That one is, you can see, is going up. The one on the bottom is flat, okay? But because one of them is sloped, right, that means there's probably a main effect. And what is the main effect? Well, what is the label that we have at the bottom there for the x-axis? It's alcohol. No alcohol versus alcohol. There's a main effect of alcohol. That means that those participants that were intoxicated were more aggressive than those that were not. Okay, that's what that means. Okay, so that's the way to do this using the graph method. That's the way to find main effects using the graph method. And if you didn't understand this, don't worry, we're going to go through at least 2 more examples. Okay, let's keep going. Now, what about interactions? We have to be concerned about interactions when we do these factorial experiments, okay, or these factorial designs. So one thing is to look for main effects, to look for a simple effect of alcohol or a simple effect of, let's say, provocation. Another thing is to find an interaction. Remember, an interaction means that the effect of one thing depends on another. So how to check for interactions using the graph method? So we're going to look at the graph again. So again, look at the lines, okay? Are the lines parallel? You look at both lines. Are they parallel? If they're parallel, there's no interaction, okay? If they're not parallel, that means there could be an interaction, depending on whether the lines converge significantly. Let me explain that, because that might be a bit confusing. So if you want to find an interaction using the graph method, we look at the graph over here, okay? Look at the graph, okay? And you got to ask yourself the questions, are the lines parallel? What that means is, do they have the same slope? If they're parallel, that means that they're both, they have the same angle. And you can see that these do not. The pink line that indicates provocation there is sloping upward. The other one is horizontal. They do not have the same angle. That means that one of them is changing differently than the other. That means there's an interaction, or potentially an interaction, depending on whether that difference, right? One is sloped, the other one is not. If the difference in the slope is large enough, okay. That's what you need to do to find an interaction. Okay, look at the lines, right? If they're parallel, that means there's no interaction. They're changing the same way. If they're not parallel, right? If one is sloped differently than the other, that means there's probably an interaction. Okay, and what that really means is that one thing is changing depending on something else, and that'll become clear as we go through more examples. Okay, so that's the way we check for interactions. Now, the interaction, we need to be able to describe the interaction. The interaction is between the label for the lines and the label for the x-axis, okay? The interaction is between our factors, okay, our independent variables. It's an interaction between provocation and alcohol. Provocation is one independent variable, alcohol is the other, okay? So that's the interaction. There's an interaction between, so because the lines have different slopes, that means there's an interaction between alcohol and provocation, or between provocation and alcohol, okay? Those are our two independent variables. So you can ask, does an independent variable have an effect on the dependent variable? Like, does alcohol have an effect on aggression? Or does provocation have an effect on aggression? If the answer is it depends, that means that it depends on the level of the other independent variable. So let me explain this in terms of the example that we have, right? We can ask the question, does alcohol increase aggression? If your answer is it depends, right? Sometimes it does, sometimes it doesn't. It depends, okay? That means there's an interaction. So does alcohol increase aggression? It depends on whether you've been provoked. That means there's an interaction. Let me explain that with the graph over here. Okay, so does alcohol increase aggression? You can see for the pink line, right? When you're looking at the pink dot on the left, right? No alcohol, right? You can see where the average is up there, it's 6. And when you look at alcohol for the pink line, it's way up there, all right? So in that case there, for the pink line, alcohol increased aggression. And remember, the pink line is provocation. So alcohol increased aggression for those that were provoked, okay? But if you look at no provocation, you look at the blue line, when you have no alcohol, the average there is 2, that's the dot there. And then you look at, for those that were provoked, I mean, for those that consumed alcohol, okay, but received no provocation, right? The blue line there, the dot there, it's still 2. The line is horizontal. It didn't change from as you go from no alcohol to alcohol, it's the same. So alcohol did not increase aggression for those that were not provoked, but it did for those that were. So does alcohol increase aggression? Does alcohol increase aggression? It depends on whether you've been provoked. That's an interaction. Now, even though I'm not looking at your expressions right now or hearing your sighs or comments or whatever it is, I'm guessing that you're probably a little bit confused right now, some of you, because this is new. So there's another way to look for interactions, to look for main effects and interactions, and that's using the chart method. So this is a table. We're going to look at tables now. And for some of you, this will make more sense. Okay, so here we have a table of the results. The other one was the graph. Okay, so if you look here, you have a table. Okay, this is like your multiplication table. Okay, so if you see no alcohol, no provocation, that's the average for those that did not receive any alcohol and were not provoked. Okay, their average is 2. That's the number that we have on the upper left. Okay, so those that did not receive alcohol and were not provoked, their average level of aggression was 2. Those that received alcohol but were not provoked, their average level of aggression was 2, right? That's the number, the big number on the upper right. So it's like your multiplication table. Look at where alcohol and no provocation meet. That's your average there. Now, for those that did not consume alcohol, so no alcohol, right? You go all the way down to where it says provocation, where they meet right there. That was the average for those that did not receive any alcohol, but were provoked. In other words, we pissed them off, okay? And then you have the average for those that consumed alcohol and those that were provoked. And that average there is 10, okay? Those that consumed alcohol and those that were provoked, they had the highest level of aggression of all. Now, I have other numbers there, and those are averages. I'll explain those in a moment. But let me explain what we're looking at here. This is a table of the results, okay? So let's go back to the graph so you understand what we're looking at, okay? Because all we've done there is we have basically put the numbers in a table, okay? For those that did not receive any alcohol, right? We look at no alcohol. We have 2 and 6, okay? So go back over here, okay, to the table. 2 and 6, no alcohol. Look, 2 and 6 going down there. Alcohol is 2 and 10. For those that received alcohol, if we look at the graph, right, you can see one number is way up there. That's 10, the pink line, right? The dot all the way at the top, and then no alcohol, the blue line, that's 2. That's all we've done. We have put the averages in this table over here. And now we need to determine if there are any main effects or interactions, okay? So I think that is described for you here. Okay, so let's go to the next slide over here. So main effects using the chart method. And remember, the chart really means there's a table. We're looking at the numbers, okay? So it says add the numbers for the first column and divide by 2 to get the mean for the first column. Add the numbers for the second column and divide by 2 to get the mean for the second column, okay? All we're doing is finding averages for the first column and for the second column. All we're saying is this over here, okay? So going down, no alcohol, 2 and 6, add those up, right? That's 8, divide by 2. Your mean there, your average is 4 for no alcohol. That column, that's the average is 4. For alcohol, 2 and 10, add those up, that's 12, divide by 2, that gives you 6 for the average for the alcohol column, okay? Yeah, and number 3 says, if there's a significant difference between the means for the columns, that means there's a main effect. There is a main effect of alcohol. So all we're saying is this: to find a main effect of alcohol, look at the column, look at no alcohol, look at alcohol, right? Calculate the average for the groups under no alcohol, calculate the average for the groups, the conditions under alcohol. The average for the no alcohol groups was 4, the average for the alcohol groups was 6, right? There's a difference there. That's a main effect of alcohol. As you go from no alcohol to alcohol, the aggression goes up. Those that were intoxicated were more aggressive on average. That's what that means. Okay, that's for the columns. Okay, now let's find a main effect going the other way. Let's find the main effect for the rows. Okay, so main effects using the chart method again. So add the numbers for the first row and divide by 2 to get the mean for the first row, and then add the numbers for the second row and divide by 2 to get the mean for the second row. If there's a significant difference between those means for the rows, that means there's a main effect. And in that case, this is a main effect of provocation. So again, let's go to the table so you understand over here. So all we've done is we found the mean going across for the first row. No provocation, 2 and 2, right? Add those up, that's 4, divide by 2, the average is 2. The average is 2 for no provocation. And then look at provocation, right? Look at the row. Second row, provocation, 6 plus 10. Add those up, that gives you 16. Okay, divide by 2, right? 16 divided by 2 is 8. The average for provocation is 8. And look, compare no provocation, the average for no provocation with the average for provocation. It's 2 versus 8. Okay, there is a main effect of provocation. Okay, that means that when you are provoked, when they pissed you off, your aggression is higher. That's what that means. Okay, so I showed you guys how to find main effects using the chart method, but we still have to think about interactions. And here's the slide for interactions. Interactions using the chart method. Find the difference between the means for the first column, example 2 and 6, write that number down, it's 4, okay? Find the difference between the means for the last column, it's 2 versus 6, basically, the difference there is 8. If the difference between those numbers is significant, then there's an interaction. An example, 8 is bigger than 4, so yes, there's an interaction. Okay, I know that probably doesn't sound like much, let me explain. Let's go back to our table over here. To find the interaction, all I'm telling you guys to do is compare. Compare that column there, no alcohol with no alcohol. Compare those columns. Look at the difference in no alcohol, right? 2 versus 6, the difference is 4. Look at under alcohol, 2 versus 10, the difference is 8. Notice how 8 is much bigger than 4. That means there's an interaction. Okay, let me show you what I'm doing with the graph. Okay, with the graph, let me explain what I'm doing. With the graph, what I'm doing is this. Look, we're looking at 2 versus 6. Difference there is 4, right? Look at the endpoints on the left and the 2 endpoints on the right. 10 versus 2. Notice how the difference for at the left, right, is smaller than the difference at the right. What that is telling you is basically, as you go from no alcohol to alcohol, the difference between the groups is increasing. And that really means that the slopes are different, okay? That means there's an interaction. Okay, so we looked at this, we looked at that. Okay, more about the interaction. So how do we describe the interaction? The interaction, remember, is between the label for the rows and the labels for the columns. Okay, provocation and alcohol, those are independent variables. That's what the interaction is. There's an interaction between provocation and alcohol. Okay, so does an independent variable have an effect on the dependent variable? It depends on the level of the other independent variable. That's what that means. Okay, so does an independent variable, does one factor have an effect on the dependent variable? It depends on the level of the other independent variable. It depends on the other factor. So another way to say that is, does alcohol increase aggression? Well, it depends on whether you've been provoked. I said that exact same thing already, except now I'm saying it for the chart method. You have to know how to read these graphs and these tables. Okay, don't worry, we're going to have other examples, but a little bit more complicated ones. Here's another study for you guys, right? Some more practice, because I know a lot of you probably didn't get it with just that one example. Okay, this one says, the following study investigates the effect of provocation, low, medium, and high. Now there's 3 levels of provocation, okay? And alcohol, yes and no. Okay, the effect of provocation and alcohol on aggression. So it's a very similar study, except that now we have 3 levels of provocation. It's a 3x2 factorial design. The 3 refers to provocation, okay? That number refers to provocation. That's the first independent variable. The second independent variable, the 2, refers to alcohol. There's 2 levels of that. So there's 3 levels of provocation, low, medium, high. That's why there's a 3. And then the second independent variable is yes and no. There's 2 levels of that. That's why there's a 2. Okay. Remember, independent variables are called factors. Okay. The study has 2 independent variables. It's an experiment, actually. The experiment has 2 independent variables. Okay. It has 6 conditions, because when you multiply 3 times 2, you get 6 possibilities. You get 6 different groups that you're going to have to compare. If there are 10 participants per condition, if you're going to have 10 participants per group, that means you need 60 total. And there'll be simple questions like that on your homework and on the exam. The more difficult ones will be, is there a main effect here? Is there an interaction, right? Look at the graph, look at the table, right? Can you spot those? Okay, so here's what the results look like. Okay, so if you look at the results, you have the pink line right there is alcohol, and the blue line is no alcohol. I graphed it this way, right? Because this is the way it makes more sense. You can graph it a different way, by the way, okay? But this is the way it makes most sense to me, all right? So you can see there. Let's think about it. First thing we need to ask, are there any main effects? We could ask, is there a main effect, let's say, of alcohol? So one line refers to alcohol, the other one refers to no alcohol. When we compare the alcohol conditions, is there a main effect of alcohol? So remember, we need to look at the lines. Are they squished together? Are they close together? Or are they spread apart? You can see they're spread apart. There's a main effect of alcohol. Now we have to ask ourselves, is there a main effect of provocation? Remember, that's the second independent variable. Is there a main effect of provocation? Let's look at low, medium, and high provocation as we go from left to right, right? What we have to ask there is we have to look at the lines, right? Are they sloped or are they horizontal, right? Are they sloped at an angle or are they flat? Flat means they're horizontal. You can see both of them have a slope. One of them has a smaller slope. The blue line has a smaller slope than the pink line, okay? But they are sloped. That means that there's a main effect of provocation. Because they're sloped, they're going up. What that's telling you is that as you go from low provocation to medium provocation to high provocation, the aggression is going up, okay? And remember, aggression is what we have labeled on the y-axis there, right? The higher you go, the more aggression. So there's a main effect of alcohol. The lines are spread out, right? They're not close together. And there's a main effect of provocation because the lines are at an angle. That means they are changing. The effect is going up, okay? Now let's ask ourselves, is there an interaction? To find an interaction, we have to compare the slope of those two lines. Do they have the same slope or do they have a different slope? Is the angle of one line different than the other? And you can see there that the angle for the pink line is much greater than the angle for the blue line. So yes, there's an interaction, okay? That means that when you ask the question, does alcohol increase aggression? Because that's what this study is about. Your answer would be, it depends. It depends on the level of provocation. The higher the level of provocation, the greater the effect of alcohol has. That's what that means. That's what we call an interaction. Let's keep going. This is what it looks like if you put the numbers in a table. So this is what you see, right? If you put the numbers in a table, so now we're going to analyze it using what's called the chart method. So remember, right, we have the numbers there. Those are the results. Those are the averages. You can see the average for low provocation, no alcohol is 2, right? When you didn't get provoked, when you got very low provocation and you got no alcohol, your level of aggression was 2, right? For that group. They have the lowest level of aggression. When there's medium provocation, but no alcohol, the average is 3. When there's high provocation, no alcohol, the average is 4. When there's low provocation and alcohol, they got drunk, right? The average level of aggression is 5. When there's medium provocation and alcohol, the average level is 9. When there's high provocation and alcohol, right? Worst possibility of all, worst combination of all. You are very pissed off and they got you drunk. Your level of aggression is 13. So remember, we have to find averages for the columns and the rows to find if there's interactions, to find if there's main effects and interactions. So this time, let's start with the rows, right? Let's start with the columns just to be consistent. Low provocation, right? Low provocation, look at the label, low provocation, going down, those numbers, right? 2 and 5, add them up, divide by 2, the average, the mean there is 3.5 for low provocation. For medium provocation, the average is 6, that's the mean. For high provocation, the mean was 8.5. So you can see that as you go from low provocation to medium provocation to high provocation, you have increasing aggression. You go from 3.5 to 6 to 8.5. right? That means that the higher the level of provocation, the higher the aggression. There's a main effect of provocation. That's what that means. And now let's look at the average for no alcohol. So going across that first row, the average there is 3. If you add all those numbers, divide by 3, the average is 3. For alcohol, right? Add 5, 9, and 13, right? Add those up, divide by 3, your average is 9. So the average for the no alcohol groups is 3, right? And the average for all the alcohol groups is 9. So as you go from no alcohol to alcohol, the average goes from 3 to 9. That means alcohol is having an effect. And in this case, it's having a large effect. Okay. You go from 3 all the way to 9. Okay. There's a main effect of alcohol. That's what that means. Now, is there an interaction? To determine if there's an interaction, what you have to do is you have to compare the differences. Right. Let's start. We're going to compare going across from low provocation to medium to high. Okay. So if we look at low provocation 2 versus 5, the difference is 3. Look at medium provocation 3 versus 9, the difference is 6. High provocation 4 versus 13, the difference is 9. So we go from a difference of 3 to 6 to 9. It's increasing, right? They're not the same. It's not staying the same. That means that there is an interaction. And remember, the interaction is always between our independent variables. So again, it's an interaction between provocation and alcohol. Okay, what that means is if you ask the question, does alcohol increase aggression? Your answer is it depends. It depends on the level of provocation. Or you could ask it a different way. Does provocation increase aggression? And your answer would be, it depends on whether you're drunk or not. Depends on whether you've had alcohol or not. That's what that means. Okay, that's what I mean by an interaction. An interaction basically means the answer is it depends. And it depends always means that it depends on more than one thing. Okay. It basically means it's complicated. It's like when you ask somebody, do you love me? And they say, well, it depends. It depends what you're talking about. Are you talking about like love, like a friend? Or you're talking about like love, like a, romantic partner, right? It depends on what kind of love you're talking about. Just to give you an example, but that might have confused you guys even more. But that's what depends means. Depends means it's complicated. Okay. When it comes to experiments, depends means that there's more than one independent variable and they're affecting each other. The level of one depends on the level of the other. That's what that means. Here's another example to give you guys some more practice. And this time I'm gonna outline it for you guys like this, and then I'll show you the results. The following study investigates the effect of relevance, low versus high, argument quality, low versus high, argument length, short versus long on persuasion. Okay, so this study wants to determine several things and how they affect persuasion. Let me give you an example of persuasion. Should you buy this product? Should you buy this car? Should you sign up for this service? That's persuasion. Think about an ad, an advertisement, right? So how relevant is the ad to your needs, right? That's relevance. How good is the argument that they're making, the claim they're making? That's argument quality. And how long is the argument? How long is the ad? Or how long is the commercial, for instance? Is it short? Is it long? All those things, how do they affect persuasion? Right? This is a 2 by 2 by 2 factorial design. This one's more complicated. Okay? 2 by 2 by 2 by 2 by 2 factorial design. It has 3 independent variables. The first 2 is for relevance. It has 2 levels, low versus high. The first 2 is for argument quality. It also has 2 levels, low versus high. And the last 2 is for argument length, short versus long. Okay, it has 3 independent variables. It has 8 conditions or groups, because when you multiply 2 times 2 times 2, it gives you 8 possibilities. There's 8 different groups that need to be compared in this study, in this factorial design, in this complicated experiment. It's not really that complicated, believe it or not, but it's a factorial design. There's many independent variables. There's 3 independent variables in this experiment. If you need 6 participants per condition, let's say you only need 6 participants per group, that means you're going to need 48 total. Okay, because 8 groups times 6 participants each will give you 48. Let's look at the study a little bit more closely so you understand what I'm talking about. And let me make sure I'm doing okay with time. Okay, I am. Okay, so here's the study in more detail. Petty and Cacioppo in 1984, they did a study. And by the way, though this study is old, we can apply it to new products, okay, today. We can apply it to the new iPhone that just came out. We can apply it to a new TV, a new car, right? It doesn't matter what the product is, but the study was done in 1984, and it still works the same way today, okay? So here's the thing. College students read arguments in favor of mandatory exams that must be passed before graduation. So they did this experiment. They had students read basically some little argument, right? They read something that says, yes, we should have, you know, an exit exam for people to graduate college. Or no, we shouldn't have exit exams for people who graduate college. Remember exit exams, right? Some high schools have them or had them where, you know, you take your classes, they tell you pass. Well, in order to graduate, you have to take this exam to prove that you've learned something, that you've learned enough in order to graduate. That's what that means. These mandatory exams that must be passed before graduation. In this case, actually, all the students read arguments that were in favor of mandatory exams, right? In favor of exit exams. But here's the thing. Some of them read arguments, or what they read was either low relevance or high relevance. In other words, for some of them, it was written so that it mattered. I mean, so that it didn't matter, that's low relevance. And for others, it was written so that it mattered, okay? That's high relevance. So in the low relevance condition, the students were told, these mandatory exams, right, that you're reading about, they won't take effect for 10 years, right? They're not gonna matter to you. You will have graduated by then. So they're not gonna affect you. That's the low relevance condition. So the exams, right, would not take effect for 10 years. In the high relevance condition, they're told the exams would be basically take effect right away. You personally are going to have to take them in order to graduate. In other words, you should care about this and pay attention because it's going to affect you. That's high relevance. Low relevance, it's not going to affect you, so you don't have to care that much, okay? What this is doing, believe it or not, is it's making you pay attention. Low relevance says, yeah, you don't have to pay that much attention. It's not that important. And the high relevance is saying, this is important. You better pay attention. That's what that is doing, by the way. It's increasing your level of motivation to pay attention, okay? Let's keep going. Now, the exams, remember, were either of low quality or high quality. I mean, not the exams, the argument for the exams. So low quality argument would be something like, well, the exams would allow you to compare your performance, the school's performance, with that of other schools. So we can see how the school's doing, right? How are we doing compared to UCLA or to USC, right? We can compare our school with other schools. That's a low quality argument. That's not a very good argument for having an exit exam, an exam that must be passed before graduation. It's basically saying, we'll see where we stand relative to other schools. Like, so what, right? That's a low quality argument. Not a very good argument for having a mandatory exam, for having an exit exam. A high quality argument would be the average starting salaries are higher for graduates with these exams. If you come from so that argument is saying, if you come from a school that has these exit exams, that means that you've proven that you really know a lot. And therefore, you're likely going to get a better job with better pay. That's a good argument for convincing students to have these exams, right? So low quality argument, high quality argument. And you combine that with whether the arguments were short or long. Short arguments, there were only like 3 sentences or 3 statements made, right? And long arguments, there were like 9 different reasons for having these exams, okay? So you combine all of that, relevance with quality and argument length. And that gives you 2 by 2 by 2. It gives you 8 different groups. And because this one is more complicated, we're gonna have to split the results in half to understand it, okay? So here's a graph giving you the results of the low relevance condition. So when students were told, hey, these won't take effect for 10 years, you don't have to care that much. That's low relevance. It's not going to affect you. Look at the lines there, right? You have the high quality argument and the low quality argument. Remember, look to find a main effect of quality. Look at the lines, right? Does high quality make a big difference from low quality? Okay, is there a main effect of quality? And you can see that the lines are pretty close together. They're not that spread out. They're pretty damn close. What that means, look at the box there, right? It says argument quality made no difference in persuasion. No main effect of quality. You give students a high quality argument, that's how much they're persuaded. You give them a low quality argument, that's how much they're persuaded. And it's not that big of a difference. Quality doesn't make that much of a difference. Doesn't make that much of a difference under low relevance. When you're told it's not going to affect you, it doesn't matter whether you make a good argument or a bad argument. They're not really paying attention. They're not really motivated to think. That's what that does. Now, when you look at argument length, ask yourself, is there a main effect of argument length? Right? Now you have to look at the number of arguments. As you go from 3 to 9 arguments, look at the lines. They are sloped. That means as you go from 3 to 9, look, it's increasing the amount of persuasion. So yes, there is a main effect of argument length. The longer the argument, the more persuasive it is. Think about that, what that means, right? If you make a commercial longer, or if you have more things on the billboard, more things on the infomercial, that means it'll be more convincing. More convincing when people aren't thinking under low relevance, when people are being lazy, okay? So argument quality made no difference. People are not really thinking, right? Number of arguments did make a difference. It appears that it's a better argument when you have more things to say, but that's just the length of the argument, not really the quality. Okay, so that's interesting. Under low relevance, that's what happens. Is there an interaction? Look at the slope of the lines. Do they have different slopes? Not really. They're kind of parallel, almost parallel, right? There's no interaction between argument quality and the number of arguments. That means that under low relevance, okay, when you're not really motivated to think, right? The effect is the same, whether you have a high quality argument or low quality argument. If you make it longer, you're gonna get an increase, okay? There's no interaction, okay? That's what that means. That is a little bit interesting, but here's something more interesting. These are the results for, oh wait, that's the graph method, and now here's the table method. Now let's look at the table, right? You look at the numbers there, those are the average. 3 arguments and low quality, the average is 4. 9 arguments, low quality, the average level of persuasion is 7. 3 arguments and high quality, 4.8. 9 arguments and high quality, 8.75, all right? So to find main effects, remember we have to calculate the averages for the rows and the averages for the columns. The rows refer to quality, low quality, high quality, right? The average for low quality, 5.50. I already have it there for you guys. That's the mean 5.50. The average for high quality, as you look across, right, is 6.78, right, for high quality. So look, low quality, 5.50, that's the average. High quality, 6.78. Is that different? Well, you might say it is different. It's a difference of like 1.3 or something like that. Believe it or not, that's a small difference. It doesn't really matter, okay? That's probably not significant. So low quality, high quality, right, didn't really matter under low relevance. Look, we're looking at low relevance. That's the big label at the top. What that means is that when you compare this line, the white line and the yellow line, they're pretty close together. The difference is between the difference there, when you look at compare the averages, only 5.5 and 6.78. It's only a difference of like 1. So as you go from low quality to high quality, it doesn't really increase persuasion that much. But look, as you go from 3 arguments to 9 arguments, the average under 3 arguments, right? When you have a short message, it's 4.40. And the average, when you have 9 arguments, a long message, it's 7.88, right? The difference there is more than 3 points. So argument length does make a difference. There's a main effect of argument length, but not a main effect of quality. Now, is there an interaction? Let's look at the difference. The difference between those numbers there, 4 and 4.8, difference is 0.8. 7 and 8.75, the difference is like 1.2 right? 0.8 versus 1.75, not really that big of a difference, believe it or not. No interaction there when you compare the differences among, for 3 arguments and 9 arguments, right? Look at the numbers there. Compare the difference between 4 and 4.8, 7 and 8.75. You know, there's not that much of a difference between those differences. That means as you go from 3 arguments to 9 arguments, it's not really much different. Look at the graph again, right? The difference here under 3 arguments, look, right? The 2 dots there, pretty close together. Under 9 arguments, they're still pretty close together. A little bit more spread out, but not much. So that's what you find under low relevance. Let's go to high relevance. That is a bit more interesting. Look at the results for high relevance. Now look at the lines, right? We're going to find a main effect. Under high relevance, remember, that means that you're told that these exams are going to affect you, that you have to care. You're going to have to take these exams, right? So let's look for main effects first, right? Because that's the easiest thing. Let's look for a main effect of argument quality, right? High quality, that's the white line. Low quality, that's the yellow line. Are the lines close together or are they spread out? You can see the lines are spread out. That means there's a main effect of argument quality. Isn't that interesting? When you're told this is going to affect you, when you're told you're going to have to take these exams, all of a sudden, if it's a better argument, it's more persuasive than it's a worse argument. Now it matters. Why does it matter? Because now you're paying attention and now you get it, right? Now you understand that, yes, there's a difference between saying this and that, right? When you care, that's when you spot the differences, when you are motivated, okay? So high quality arguments produce more persuasion than those of low quality, right? You can see the white line there versus the yellow line. That means there's a main effect of argument quality. Now let's look if there's a main effect of number of arguments as you go from 3 to 9, okay? So look, longer arguments increase persuasion when of high quality. As we look at the white line, right? As we go from 3 to 9, the persuasion went up, okay? It went up. But when you have a low quality argument, the yellow line, as you go from 3 to 9, the persuasion goes down. Okay. You know what that tells you? In one case it went up, in one case it went down. Is there a main effect of argument length, having 3 versus 9 arguments? The answer there is no. Argument quality didn't increase persuasion. In one case it went up, in the other case it went down. And believe it or not, it goes up for high relevance, it goes down for, it goes up for high quality, it goes down for low quality. So when you compare the averages, it didn't make a difference because it went up for one and then the other one went down, so it canceled the effect. There's no main effect there of argument length. Argument length makes it better when it's a good quality argument, but it makes it worse when it's a bad quality argument. So it does not increase persuasion to have a longer argument. Not overall. It only does it for high quality, but it does the opposite for low quality. So overall, it doesn't have an effect. But as you guys are thinking, some of you might be thinking already, wait a minute, there's something going on here, okay? Yes, it did increase it, at least in one, but not the other. What is that telling you, right? That's telling you there's an interaction. That's what you're thinking about. Look at the slopes of the line. For one of them, it's going up. It has a positive slope. The other one's going down, has a negative slope. There's an interaction between argument quality and the number of arguments. That's what that's telling you, okay? So when you ask, right, is it more persuasive to have a longer message? The answer is, it depends. It depends on whether you have a high quality argument where it does work, or whether you have a low quality argument where it doesn't work, where it actually makes it worse. A longer argument of low quality is actually less persuasive. It makes you want to believe in the message even less. So believe it or not, this is a very interesting effect. When you don't care, when it's low relevance, okay, quality doesn't matter, but making the message longer makes it more persuasive. when it's a high relevance argument, right? When you are told that you have to care, that you have to pay attention. Now quality makes a difference. Okay? But argument length makes a difference, a good difference in one case, but not the other. There's an interaction. This is a very important message, believe it or not, okay? It's talking about how persuasive ads are, how persuasive commercials are when you're going to buy a new product, a car, a phone, or whatever it is, right? You have to think about whether the message is going to work. And when you're sitting there on your couch watching TV and you get this commercial, are you really motivated to think? No, you're not, right? That means we're operating under these set of circumstances, under low relevance, which means that when they throw all sorts of things at you, a longer message, or they throw at you, let's say, an attractive spokesperson, you know, shiny colors, mood, people having a good time, whenever they try those things, it's likely to work because you're not really thinking. The quality of the argument, that doesn't really matter because you're not really thinking. That's what that means, okay? If you take my social psychology class, I explain this stuff further. We talk about persuasion, and you'll understand this further. Here, I'm just talking about how to analyze results. And here's the high relevance condition using the, looking at a table, okay? Using the, what's called the chart method. So again, we have to calculate the averages for low quality and for high quality. The average for the two groups under low quality is 2.5. The average for the two groups of high quality, 9.75. For low quality, 2.5, high quality, 9.75. So as you go from low quality to high quality, yes, that makes a difference. There's a main effect of quality. Higher quality arguments are more persuasive. Higher quality arguments are more persuasive than low quality arguments. Look at argument length. Look at 3 arguments versus 9 arguments, or length of the message, okay? 3 arguments, that's shorter than 9 arguments, okay? So 3 arguments, average going down for 3 arguments, 6. Average going down for 9 arguments, 6.25. The length of the argument, or the number of arguments, did not make a difference. There's no main effect of argument length. The average 6 and 6.25, it's almost the same. There's no main effect there. Why is there no main effect, right? Look over here. Again, look at this. As we go from 3 to 9, in one case it goes up, in the other one it goes down. So the increase is canceled by the decrease. That's why the average here is 6 versus 6.25. But is there an interaction? You bet there is. You can see the interaction very easily here with the graph method, right? You can see those slopes are very different. One is positive, one is negative. You can also see it with the table. Compare 4 and 8. The difference there is 4. And then 1 and 11.5. The difference there is 10.5. Right? Much larger difference under 9 arguments. So there's an interaction between quality and argument length. And by the way, all sorts of studies have been done where instead of looking at argument length, they look at the attractiveness of the spokesperson. You know how they use good-looking people on TV to sell products or to sell beer or cars or whatever it is? They also looked at mood, right? They also have looked at mood, right? You know how they're showing you a car and they're driving fast or they're having a good time because of this beer or whatever it is. That's mood. It all works the same way as this experiment that I'm telling you guys right here. Okay? When you don't care, these things work. When you are thinking for yourself, then all of a sudden, making the argument longer, having an attractive spokesperson, mood, all that stuff doesn't really work that much, okay? I will explain that a lot more if you take my social psychology class. Here's another example. For this one, I'm not describing the study for you guys for the sake of time, because if I did, this would take us a whole week, okay? But I've shortened it so we can get out of the way today. There is something known as a crossover interaction, and it looks like that. When you graph the results, it makes an X. This was a study, and you could see it labeled there, that looked at the effect of teacher expectations and age on exam score. So you know how sometimes teachers, they think that you're smart, they care about you, right? They expect you to do well. And sometimes they think you're dumb and they expect you to fail, right? How does that affect how you do on an exam? How does that affect your performance? And also age, right? Whether you're young or are you older, how does that work? This is what the results that were found for one study, okay? When you look at the effect of teacher expectations and age on exam score. So you can see that, let's look at the blue line first. Look at the blue line, okay? The blue line stands for 7-year-olds, little kids, right? 7-year-olds, little kids. When the teacher had low expectations, you can look at there where it says low expectations and a 7-year-old. So that dot on the lower left, okay, that's low expectation and a 7-year-old. So when 7-year-olds have a teacher that has low expectations, a teacher that thinks they're dumb, that expects them to fail, and they are also young, they don't score very well. The exam score is down there, it's 100, okay? But when the teacher has high expectations for those 7-year-olds, the dot on the upper right, so look at high expectations, go up to the blue dot. That's when the teacher cares about the students, thinks they're smart, right? Expects them to do well. Now students do better, okay? But look at the effect for 17-year-olds. The effect for 17-year-olds is reversed. When you have low expectations, when the teacher thinks you're dumb, thinks you're dumbass, right? Doesn't expect you to do well. If you're a 17-year-old, what happens? It's like, screw you, I'm gonna show you, I'm gonna work harder, and I'm gonna prove you wrong. That's what happens for 17-year-olds, okay? Low expectations, and the teacher has low expectations about them, and basically they're 17-year-olds, right? Look at that pink dot on the upper left, right? That's their score, 120. When the teacher has high expectations, and you have a 17-year-old, when the teacher basically expects that you're gonna do well, and thinks you're bright and that kind of stuff, you don't do as well as a 17-year-old, according to this study. Why is that? What is that saying? For this particular study, what I think was happening is that when you have a 17-year-old and the teacher saying, yeah, you guys are smart, you guys will be okay. What happens to what do these teenagers do? They don't try. They don't study. They say, oh, the teacher says we're going to be fine. It's going to be easy. And they don't study, and then they do worse. This is a very important finding. Not all studies will have these kind of findings, okay? But this is a very important finding. What it says, the important thing of what it says is this: when kids are young, that's when they're more susceptible in a negative way to teacher expectations. If you're young and the teacher doesn't believe in you, thinks you're a dumbass, the teacher's not going to teach you very well. The teacher is not going to give you much attention, and you're going to do worse, okay? If you have a good teacher when you're young, that's good. Then you'll do better. For 17-year-olds, there's something different going on that has to do with effort, right? But those are that results. That's called a crossover interaction. Now let me explain. Okay, let's think about main effects first. Is there a main effect of let's say teacher expectations? As you go from low expectations to high expectations, is there a main effect? You have to look at the lines. Are they spread out or are they close together? What happens is they make an X. In one case, one line goes down, the other one goes up. And you know what that does? That they cancel each other out. You have no main effect of expectations. Sometimes good expectations make things better. Sometimes good expectations makes things worse. There's no main effect there. Let's look at age. If you look at the slope of if you look at the lines, are they does it work here? Let's see. How do we look at the main effect of age? You have to look at you have to look at the lines, okay? Are they do they have a slope or do they not have a slope? Okay, are they horizontal or are they not at an angle? They are at an angle, but one of them has a positive slope and the other one has a negative slope. One goes up, the other one goes down. Believe it or not, that cancels out the effect because one goes up, the other one goes down. It's like one goes positive, the other one goes negative. So believe it or not, there's no main effect of age either. No main effect of expectations, no main effect of age. It's like expectations didn't make a difference and age didn't make a difference. Here's the thing, we know it did. It's just more complicated, okay? What we have is an interaction between teacher expectations and age. So So we can ask this way, do teacher expectations affect student performance? If you ask that question, the answer is it depends on the age of the student. If students are young, it makes students better when teachers have high expectations. If students are teenagers, if they're older, then having higher expectations might actually make things worse, or at least it did for this particular example. That might be a bit confusing, right? But when you have a crossover interaction like this, what that means is there's no main effects, but there is an interaction. You can clearly see the interaction, right? When you compare the slope of the different lines, right? They're not parallel, right? The lines are not parallel. They have different slopes. There's an interaction there. Now, I think, do I have the table? Look at the table. The table makes it a bit more clear, okay? If you calculate the average for 7-year-olds, so the row going across 100 and then 120, add those, divide by 2, the mean is 110. For 17-year-olds, the average 120 versus and 100, add those up, divide by 2, the average is 110. So look, as you go from 7-year-olds to 17-year-olds, right, the average is the same. The mean is 110 versus 110. There's no main effect of age. Age didn't make a difference on the score here, okay? It didn't, okay? Here's the thing, there's more to this, probably because the 17-year-olds, they had a basically a harder exam. Think of it this way. It's like an IQ test, right? The 7-year-olds, they had an IQ test that was appropriate for 7-year-olds. The 17-year-olds had one that was appropriate for 17-year-olds. And they both have about the same average. Okay. Now, as we go from, now let's compare expectations. Let's look at low expectations, 100 and 120. The average is 110. Look at high expectations, 120 and 100. The average there, when you combine those two, divide by 2, is also 110. So as we look from low expectations to high expectations, 110 and 110, it's the same. There's no main effect of expectations. Now, if we compare the differences in low expectations, 100 versus 120 and 120 versus 100, you might think, hey, the difference is the same there. Difference of 20, difference of 20, there's no interaction. But yes, there is an interaction, because in one case, it's a negative 20, and the other one, it's a positive 20. So you have to think, one is going down, the other one's going up. So there's an interaction, and the interaction is always easier to see with the graph, okay? And that's a special case of what's called a crossover interaction. And by the way, if you do an experiment where you look at multiple, at least 2 independent variables, and you find a crossover interaction, that is actually something that's very rare and actually potentially very interesting. And that's more likely to get published. We all know, for instance, that teacher expectations make a difference on how students score, right? That's when you look at a study with one independent variable of teacher expectations. But if you look at teacher expectations and age, if you combine those two independent variables, and you find you find that it works for one, but not the other, or you find a crossover interaction, that is interesting. That is more likely to get published. I'm telling you guys, when you become a researcher, right, you go to graduate school or you're a researcher, if you find crossover interactions, those are harder to explain, but they are more interesting. They are more likely to get published. Just to find a main effect, to find that alcohol increases aggression, guess what? We already know that. To find that teacher expectations increase scores, we already know that. That's probably not going to get published. Those experiments are too simple. You need to look at multiple independent variables and find what we call interactions. That's what you need to find, interactions. You want to get published? Find interactions. Interactions simply means that the effect of one thing depends on the effect of another. And that means basically that you have a very interesting situation that you need to explain. That is more likely to get published. We already know these things like alcohol work. We already know that expectations work. We already know that lots of things work. To show that one thing depends on another, that's what we don't know. That is more complicated. That's more complex. And that is more likely to get published. That's more meaningful. To figure out the complexity of the real world, right? When you look at one thing at a time, that's simple. But the real world is complex. In the real world, you have a bunch of things interacting all at once. And if you can figure out how that is, that's likely to get published. All right, guys, that's where we'll stop.